So last time we had the problem that if I asked a pigger to greet, it didn't work. It got into an infinite loop because it tried to convert the word my in hello, my name is to Pig Latin, and it doesn't think that y is a vowel, so it loops forever. So I'm going to solve this problem in a really bad way. So again, this is code you would never write in practice, but it's a good demonstration. Need to be instantiate pigger porky. I'm saying this again because I now have a new class pigger. That's important too. When you redefine a class, any instances you may have made are still instances of the old class. So if you want instances of the new class, you have to make them over again. You will find often that if you redefine a class, the easiest thing to do is quit scheme and just start it again and load your new definition in. Okay, so what happens, first of all, if I ask pp quote greet, it says, Elohe, my aimne is a orkipe. So it didn't try to convert this to Pig Latin. That's the wrong solution. That's why you wouldn't write it like this. In practice, you would try to make it so this comes out I may, Y-M-A-Y. But what I did, here it is. So we're looking at the say method and what to do if it's a word. Because if it's a sentence, which is what I gave it, it just maps ask self say over the words. But let's say it's a word. We have this if. If the word is something other than my, let's look at the false case first, then we ask self, quote, piggle stuff, which is what it said before. But if it is the word my, then I call a procedure usual. So now we're going to have a list of the procedures that are part of this implementation. And I'm putting define class in brackets because it's a special form rather than a procedure. We have instantiate. We have ask. And we have usual. And that's it. We're not going to spring any more implementation procedures on you. This is it. Usual says, send this message to this object, like ask, but start right at the else clause with the parent. Send it right away to the parent without looking at the child's methods. So usual say says, I don't want to do this say method. I want to do my parent's say method. The reason it's called usual is that when you make a child class, you're saying the parent is sort of the general thing. There's lots of things like the parent, and we're specializing that in some way. Like, of all the people in the world, only a few go around speaking Pig Latin all the time. So usual means say it the usual way instead of in Pig Latin. That actually hits an answer to the question somebody here asked before. What if you have a pigger and you want it not to speak Pig Latin? You can say usual say. It won't work, however, to say usual ask because we're using the parent's ask method anyway. The parent would have to say usual to not speak Pig Latin on an ask. But you can make it not speak Pig Latin on a say by saying usual say. But only inside a method of this object. You can't type that at a scheme prompt. The usual procedure is defined globally, but it won't know what to do unless it finds a variable self. Because it does a sort of special kind of ask self that says, don't look for your own methods, just ask your parent. Okay, questions about that? Yeah. Yes. What if you have multiple parents? It's not just a problem for usual. It's the same problem as if you don't have a method at all. So here's the deal about multiple inheritance. Okay, so I have two parents. And here's grandma. Okay, now, the priority rule is whichever one you put first in the parent clause, that's the one you want to have priority, right? So the answer to the question, which parent do we ask, is in this case, first we'll ask mom, and then we'll ask dad. Okay? But what if neither mom nor dad, no, I'm sorry, what if mom does not have a method? So I send it the message foo. There's no foo here, there's no foo here. Grandma has a foo, and dad has a foo. Okay? Well, if mom had a foo, it would be clear that I want to use mom's, because I put her first in the parent clause. But now the question is, which is better? A more specialized method foo, because the one that my dad has is closer to me, right? Less generic. Or a more generic method that's inherited rather than actually in my first choice parent, my mom. Okay, you get the problem? The reason it's a problem is that I can construct examples in which grandma's foo is the right answer, the thing you want, and you can also construct methods in which dad's foo is the thing you really want. Okay? So it's up to the designers of object-oriented languages to try to resolve that question and do what you mean. And doing what you mean, everybody seems to think these days is not possible. And so they just throw up their hands and say, look, we're not going to do multiple inheritance. And it's because of this grandma versus dad problem. That's what makes it hard. Setting it up to work right is not hard, but knowing what to do is hard. Is that a hand up? Yeah. The instance of grandma that we make, okay, when I make an instance of me, remember these are classes. When I make an instance of me, I implicitly make an instance of mom and an instance of dad. Making an instance of mom implicitly makes an instance of grandma. Okay? So that instance of grandma herself is going to point to me, not to mom. For the same reason that moms point to me, namely, if you say ask self something, you want to do the most specific possible thing. Right? And if I have a method for it, then that's clearly the most specific. Our object system, this one, if you use multiple inheritance, does not use the most specific possible thing, because I did a different form of throwing up my hands, namely, do whatever's easiest to implement. And what's easiest to implement is when I send that message to mom, I've decided that I don't have a method for that message, so I send it to mom. Mom doesn't tell me how she got a method. She just says, yes, I can handle that. So I don't even know whether it was mom or grandma who actually defined a method for that message. Okay? So therefore, grandma beats dad in our system, because in my object, the only one that knows that there's any multiple inheritance going on, my object has no way of knowing whether it was mom or grandma who provided the method. Now, we could make it possible. We could send mom a special kind of, do you have this? Can you handle this message? That says, can you handle this message by yourself? You know, and we would have to build in every object knowing how to receive that kind of thing. And so we could do it. Anything is doable. But we just did the easy thing, which is let the system do what it naturally does. In the same way that, you know, if you just naturally traverse a tree, it's going to be a depth-first search, not a breadth-first search. Right? It's the same thing here. Yeah? Usuals within usuals. When you say within, do you mean as an actual argument expression?
Yeah, like I'm saying the usual
usual of say stuff. You can say that, but usual isn't some special kind of syntax. It's a call to an ordinary scheme procedure. When you say usual say stuff, what you get back is not an object or a method or anything. You get back a sentence, right? So to usual a sentence just doesn't make any sense. But also, and this is why multiple inheritance is so weird. When you delegate a message to some other object using parent, you're not supposed to care how it's implemented. Your parent's implementation is a black box to you. As far as you're concerned, the parent itself handles all the messages. So if you put in something that makes the assumption that your parent has a parent, and then they change the way that parent class is implemented because one of the other 4,999 programmers wrote that class, then your code is going to stop working. Okay? Multiple inheritance really is a can of worms.